Hello friends, let's do some more limits for x running towards infinity. I hope you enjoyed the last video. Let's move on and see what's happening in this video. So we're having a limit x towards infinity. For example, we are having x plus 1 squared divided over x cubed minus 1000, or maybe let's make it a million x squared, just for you to see the power of infinity. Well, you see that the numerator is behaving like a quadratic function, so there is nothing special. We're just having the binomial formula x squared plus 2x plus 1. The denominator is just stronger because it's having a cubic power. So what we're doing is we're multiplying it times 1 divided by x squared here and there. And now you immediately see what's happening. We're having a limit x towards infinity, 1, 2 divided by x, 1 divided by x squared, x minus just 1 million. Well, even though it's a pretty big number for our finite world that we're living in, 1 million is nothing if you compare it to infinity. So those two fractions are disappearing pretty quickly. The numerator is running towards 1. The denominator is becoming infinitely large. So we're having 1, which we're dividing by a huge number, so the outcome is 0. That's pretty clear. Well, if we multiply it out, it takes a lot of time. Maybe we should just see a shortcut. Well, let's try. Second example would be, let's say, limit x towards infinity. And let's say we're having 2x plus 3 cubed. And then, what I had to, let's say, 3x plus 4 squared divided over x minus 1 to the power of 5. Well, you see, if I would take all the binomials and multiply it out, it will take a lot of time. But I can see that this factor is behaving like x cubed. Well, actually like 8x cubed, because if I cube it, I'm going to have 2x cubed, which is 8x cubed. This one is behaving as 9x squared. So my numerator is 8x cubed times 9x squared. It's approximately 72x to the power of 5, right, on the long run. The denominator is just x to the power of 5. All the other powers are unimportant since x is running towards infinity. So this is straightforward 72, right? Now let's see what will happen if we have a limit x towards infinity, and let's say we have x squared divided over 3 plus x square root of x. Well, you see the numerator is slightly stronger than the denominator, so you have to develop this kind of feeling. Okay, so what I can do is I can write it as a limit x towards infinity. Well, this is actually x square root of x times square root of x. Can you follow me? And here we're taking x square root of x outside of the parentheses, so we are having 3 divided over x square root of x plus 1, parentheses closed. Now we can cancel those two, and now you see the fraction is running towards 0 because this is getting infinitely large. 3 divided by a huge number is running towards 0, so we're having actually a 1 in the denominator and infinity in the numerator. So the outcome here is just infinite. And number 4, so the last one for tonight is limit x towards infinity. We're having square root out of x in the numerator and square root out of x plus square root out of x in the denominator. So how can we start? Well, we would like to cancel square roots. So let's somehow write it down. So I would like to take a square root of x outside. What would I have? Look at this. So first of all, if I kick it out, what do I have here? I have 1 divided square root out of x. Is that correct? Yeah, because if I bring it inside, I will have x divided by the square root of x. That would give me a square root of x. So I would be having it for this one. And for this, I need, is it more? I think I should have 1 here, right? Look at this. Is it fine? Think so. So if I multiply it, I'll have to square it because I bring it under the square root. So I would have x divided over square root of x, which is this one, which is fine. And this one is becoming x. So that's cool. Yeah, that's right. I'm canceling it. And you see I'm having 1 in the numerator, and this one is approaching 0. And so this is 1 as well. So I'm having 1. Even though it looks like square root of x could have some contributions to the limit, it has non-contribution, as you see, because the normal square roots, this one and that one, are just too strong, and this expression doesn't mean anything. Thanks for watching, guys. See you in the next video. Bye bye, all the best.